Lesson 8 is all about equations of circles, and in 8.1 we're going to create an equation for the circle in this graph. So in this graph we have a circle that is centered at point 1, 2, and it has a radius of 3. Remember that a radius is just a segment inside the circle that connects the center to an endpoint on the circle. In this case it connects to the endpoint xy, and we want it to just kind of connect to a general point on the circle, because we want our equation to represent any point on the circle. So if we want to be able to use Pythagorean's theorem now, this is where that kind of the triangles come into play, because remember Pythagorean's theorem is a formula that we use to find missing side lengths of right triangles. So that's why you can see the right triangle drawn inside the graph. So from the radius, we created like a vertical leg and a horizontal leg, and those are going to kind of help us fill out the rest of our equation. So Pythagorean's theorem, that's a squared plus b squared equals c squared. And a and b are always the legs, c is always the hypotenuse. So we already know c is 3, so I can just go ahead and put a 3 in for c, and then I have to remember that squared part. So the squared part still comes down, so it'll become 3 squared. And then a and b have to be the legs. So I'm going to say that a is this leg right here, the one that goes like kind of horizontally. And if we look at that one, it's like 1, 2 with a little bit extra. It's like a little bit more than 2 units, but it's not quite 3. So we don't actually know that length, but we can find that distance by like figuring out the distance between the points. So since that is just like a horizontal change, we can find that distance by subtracting the x coordinates. So this x coordinate is just x, and this x coordinate is 1. So that distance would be x minus 1. Anytime you want to find the horizontal distance, you can just subtract the x coordinates. I'm going to make a note of that down here. So a is going to be the distance between the x coordinates. So it'll be x minus 1, or the absolute value of x minus 1, because distance is always positive. So this is what I'm going to put in for a in the formula. So it would be parentheses and then the absolute value of x minus 1. And then we have to remember the squared part still. So that absolute value of x minus 1 went in for a. That was one of the legs, and that distance came from, one more time, just like the distance between the x coordinates, x minus 1. And then to find b is going to be the like vertical kind of like change between the 2 points, so the side or the leg that goes up and down. So again, we don't really know this distance. It looks like a little bit more than 1, but not quite 2. So in this case, since it's the vertical change, I can find that change by subtracting the y coordinates. So I'll say b is the absolute value of, so this top y coordinate, like the one above it, is y, and then the lower y coordinate of that segment is 2. Oops, I underlined the wrong number, but y, and then the lower y coordinate is 2, so minus 2. So absolute value of y minus 2 is going to give us this distance right here. So we'll go ahead and take that and put it in for b. So it'll be plus parentheses absolute value of y minus 2, and then let me move this over so I have a little bit more space. And then close the absolute value and close the parentheses, and then just don't forget the squared part. So we have the absolute value of x minus 1 squared plus the absolute value of y minus 2 squared, and then plus 3 squared. I'm going to run through that one more time on the triangle just to kind of show like why or how we got each different value. So c is always the hypotenuse that's given to us, that's 3. A, I said, was this side right here, the like kind of like leg that goes side to side, and we don't really know that distance because it looks like it's a little bit more than 2 units, but it's less than 3 units. So to find that distance, we had to subtract the x coordinate since it was like a horizontal change. So it was x minus 1, the absolute value of that, to make it positive. And then for the like second or the other leg over here, that was our b, and again that was like a little bit more than 1, not quite 2, so we didn't actually know the distance. So to find that distance, we had to subtract the y coordinate since it was the vertical change, so y minus 2, or absolute value of y minus 2. And then now, like, yes, we want to talk about in terms of absolute value because it's a distance. However, because we took these distances and put them into Pythagorean's theorem and they're ending up being squared anyways, anytime you square a number, it ends up being positive as well. So having the absolute value bars in our equation is kind of like redundant. So it's doing the same thing of making like your final outcome positive. So we can go ahead and take them off. So we can just say x minus 1 squared and then plus y minus 2 squared and then equals 3 squared. And we're just going to leave it like that as our final answer. So an equation of this circle, or the equation of the circle, is x minus 1 squared plus y minus 2 squared equals 3 squared. Okay, so for 8.2, we're going to end up deriving like just a more general formula of a circle, but I want us to take a look at our final answer here one time and kind of compare these numbers to the actual values from our graph. So we know that that 3 came from like the radius or the hypotenuse of the triangle. So that number right there is the radius of our circle. And then notice that like for like the first part, it was x minus 1. And then the second part of the equation was y minus 2. And then look at the coordinates of the center of the circle. The x coordinate is 1 and the y coordinate is 2. And that's not just by chance. So these two numbers, the like y minus, or the x minus 1, the y minus 2, those are going to help give us our center. Center was 1, 2, and then was x minus 1 for the x's, y minus 2 for the y's. Okay, so that builds into 8.2, which is just standard form of equations of circles. And like I said, we're just going to take our answer from part 1 or 8.1 and just generalize it for like any circle. So in order to do that, we have like kind of this graph right here. So in when we're writing like equations of any circle, we usually use the letters h, k as like the center, and then r for radius. So if I wanted to like rewrite my answer from, I'm just going to copy this whole thing down, rewrite my answer from 8.1 to represent any circle, then I would have to take out the 1 from the center of 8.1. And in this case, I would have to put an h there because h is that like general x coordinate for the center. And then I would also have to take out the 2 from like the example in 8.1. And I would have to put a k there because k is that like general letter that we use for the center of a circle for the y coordinate. And then not every circle has a radius of 3, so we'll definitely have to take out the 3. And we'll just put an r there. And then now this formula will help you write the equation of any circle. So h and k are going to be the like center. H is the x coordinate, k is the y coordinate, and then r is the radius of the circle. Okay, one thing to keep in mind that like, yes, there are minuses here. So that means that like kind of whatever you put in for h and k, it's going to end up looking kind of like the opposite symbol, and that's okay. That's how it's supposed to be. And if you ever look at an equation and have to identify the radius from it or the center from it, you're going to have to kind of almost switch what h and k look like, and that'll make more sense after a few examples. Okay, so this formula is really important. This is the formula we're going to use to write the equation of any circle. So I would save it, put on a sticky note somewhere on the top of your paper so you can always reference it back. So one other note to add is just that the center, and I know it's on the graph, which is really important to have it and to remember it. So the center of the circle in this equation is the point h, k. Okay, so for example 1, state the center and the radius of the circle represented by x minus 4 squared plus y plus 3 squared equals 4. So I'm going to rewrite the formula like right beneath this, and then we're just going to kind of try to restructure the equation that we're given so that it looks identical to the formula, just with our actual like h and k and r values in there. So underneath the equation, I'm just going to leave a space because I'm going to put a line underneath it, but underneath that space, I'll rewrite the formula down here. So the formula itself is x minus h squared plus y minus k squared, and then equals r squared. So what I want to do is I want to try to rewrite my equation so that it looks almost identical to like the formula, including having minuses there and including having like r squared at the end. So the first part, the like x minus 4 squared, that already kind of looks like identical to what we're supposed to have. So that part I don't really need to change. I'm just going to rewrite it down here. So x minus 4 squared. And then the second part, y plus 3 squared, it's supposed to be a y minus a number squared. So the like k value that's turning that what was a y minus into a y plus must be a negative k value. So I'm going to rewrite it with that. So it'll be y and then minus from the formula. And then I can't just put a 3 here because like that's changing the value. Like one is a y plus 3 and one is a y minus 3. So the like k that's changing that y minus into a y plus 3 is a negative 3. It's a double negative, and then close the parentheses and square it. So anytime you see like a y plus where there should have been a y minus, it's because of a double negative in there, because that first minus is there automatically from the formula. To turn that first minus into a plus, it requires a double negative. And then at the end, we have just a 4 here, but we're supposed to have a number squared to get r squared. So I can rewrite 4 as 2 squared. And then now I'm rewriting it like that. It makes it a lot easier to identify what h, k, and r are. And you don't have to do that every single time, but I will say if you don't do it, it is a lot easier to make a simple mistake. So now we just have to figure out what each letter is, and they line up perfectly. We don't have to worry about changing the signs or anything like that. So h would be 4. It's not negative 4 because this minus is a part of the formula. So h is 4. And then k is negative 3. I know it was a plus 3, but remember that first minus is there, and that negative 3 is what turns it into a plus. So k is negative 3. And then r is just 2. Again, like we know it was a 4 initially, but in the formula itself, it's r squared. So we have to figure out, okay, 4 is what number being squared? That number is going to be r, so r would be 2. Okay, so we have h, we have k, and then we have r. That's enough information to be able to state like what is the center and what is the radius. So the center is the point, you can see it up here, is the point hk. So we just have to put h and k together, so it'd be 4, negative 3. And then the radius is just r, so our radius is 2. And then we're done. Okay, so our center was at 4, negative 3. Our radius was at 2. And then one thing I just want to stress before moving on to this problem, and it'll continue to pop up in all of our circle problems, is that when you see like an x minus 4, that would mean that you have to kind of, it's going to be the opposite of what it looks like it should be. So like h was positive 4. Versus like if you see a y plus 3, it's going to be the kind of the opposite of what it looks like it should be. So k was negative 3. And the reason it's the opposite of what it looks like it should be is because we have these minuses in the formula. And minus just means opposite. Okay, so moving over to example 2, write the equation of the circle. So I'm going to get my formula down again. So the formula is x minus h squared plus y minus k squared, and then equals r squared. So in order to be able to write the equation, we need 3 values. We need the x-coordinate from the vertex, we need the y-coordinate from the vertex, and then we need the radius of the circle. So I kept saying vertex, but we need the x and the y-coordinate of the center. I'm like used to quadratics and saying the vertex, but we need the center. Okay, so you can see the center is at A. So that point, if you start at 0, 0, you go right 2, and then you go down 2. So that point is 2, negative 2. So that would mean for h, it would be 2. And then for k, it's -2. So we can go ahead and just start putting those in right away. So h is 2, k is -2. So it'll be x minus 2 for h, and then plus y minus -2 for k, and then don't forget the squared at the end of each parentheses. If you want to simplify the double negative into a plus right away, that's fine. I'm going to do it in the next step though. And then equals the radius squared. So now we're just going to need to find the radius. So I would recommend creating like a vertical line or a horizontal line from the center to like the outside of the circle. So from point A, like the radius would be 1, 2, 3, 4, 5, 6 units. So this is 6, and you can double check it if you want, but 1, 2, 3, 4, 5, 6 units from the like radius to, or sorry, the radius is 6 units. So it's 6 units from the center to like the outside of the circle. So the radius itself is 6. So it'll go there. And then the squared part is still a part of the formula, so we have to like copy that down again. So those squared parts are staying there. The only time they would disappear is if we simplified it at the end. Okay, so for the like x minus 2 and the y minus -2, we're going to keep those squares. We are going to simplify the double negative, and then at the end we can simplify the 6 squared to get our final answer. So it'll be x minus 2 squared, and then plus y minus -2. You would never just like leave the double negative there, even though you like there's the negative from the formula, there's a negative from the y coordinate. You would always simplify it to y plus 2 for your final answer. So y minus -2 turns into y plus 2 squared, and then equals 6 squared, so equals 36. So the equation of the circle is x minus 2 squared plus y plus 2 squared equals 36. Okay, so moving down to example 3, this is the last one. So one point on circle K has the coordinates 14, -6, and the center of the circle is K, which is 4, -5. Write the standard form of the equation of circle K. Okay, so same thing, I'm going to start with our formula. So it's x minus h squared plus y minus k squared, and then equals r squared. Okay, so we know that h and k are the center, and they tell us that the center of the circle is at 4, -5. So we know that h is going to be 4 and -5 is going to be k. And keep in mind, like, yes, h will always be the like x coordinate, the first number in the vertex or the center. And sorry, it's going to be a habit to break. So h is always the first number on the center, the x coordinate, and k is always the y coordinate from the center. Okay, so we're going to put 4 in for h right here, and then we're going to put -5 in for k right there. So we'll do x minus, this is supposed to be a 4 for h, so x minus 4 squared, and then plus y minus -5 for k. Close it out and square it, and then equals r squared. So we don't know the radius yet. It doesn't tell us what the radius is, and we don't have a picture to just count it. It says one point on circle K has a coordinate at 14, -6, and then the center is 4, -5. So if you picture like any circle, if we have a center and then a point on it, the radius is the distance between the center and that random point on the circle. So we have the distance formula that lets us find the distance between any 2 points. So that's what we have to use to find the distance here, or the radius here in this case. So the distance formula is d equals the square root of x2 minus x1 squared, and then plus y2 minus y1 squared. And it doesn't matter which point you make, which for your, like, in terms of x1, x2, and so on. Just pick one. So we'll say this is, like, my point 2. And then this is my point 1. So this will be my x2 minus x1. So it'll be 14 minus 4 to start. So x2 is 14. Minus x1 is 4, squared, and then plus for y2 minus y1, it'll be negative 6 for y2, and then negative 5 for y1. So it'll be negative 6 minus negative 5 squared. And then inside here, 14 minus 4 is 10, and then we have to square the 10. And then in the second parentheses, this one's kind of tricky with all the negatives. So negative 6 minus negative 5. Remember, if you have a double negative, it turns to a plus. So it's like negative 6 plus 5, which is negative 1. So this would be plus negative 1 squared. And then we can square both now. So it'd be 10 squared is 100, plus negative 1 squared is negative 1 times negative 1, so that would be positive 1. So it'd be the square root of 100 plus 1, so 101. So that's the distance between the 2 points. And again, just to kind of sketch it, oh, that's not a circle. But if we have the center and a point on the circle and we find the distance between those 2 points, that's going to give us the radius. So this distance is the radius. So we can take that square root of 101 and put that in for r. So it'd be the square root of 101, and then squared still, because it was r squared. And then now we can just finish simplifying it. So it'd be x minus 4 squared, and then plus y minus negative 5. Again, we'd never leave the double negative there. We would simplify it to y plus 5 squared, and then equals, if you have a radical that is being squared, so like the square root of 101 squared, those are kind of opposites of each other. So the radical and the squared cancel each other out. So it would just be left with 100. So it'd be x minus 4 squared plus y plus 2 squared plus 101. Okay, so notice all of our final answers have ended up looking very, very similar to that original formula, this one up here, meaning that they all have the x minus h type of parentheses squared, y minus k parentheses squared, and then just a number at the end. So you would never have to simplify this or FOIL it or anything like that. You want to see parentheses squared for the x's, parentheses squared for the y's, and then is equal to the radius squared, and that's as simplified as we would like it to be.